So today we're going to just cover the secant and the cosecant portion of the section 5 notes. We're not going to cover tangent for the test, which is next Wednesday. We'll cover that after the test. So the test is going to cover the quiz you took on 6.1 to 6.3, as well as the graphs of the sine, cosine, secant, and cosecant. I will release those quiz results on Tuesday, so you can use those to study. So anybody who has missed the quiz and needs to make it up, please try to make it up Tuesday morning or today after school. And otherwise, I'm going to release the results on Tuesday. So let's go ahead and take a look here. So today we're going to learn how to graph again, secant and cosecant. So let's first take a look at the graph of cosecant. So again, remember, we're more familiar with seeing the abbreviation for cosecant, which is CSC. So this is how we're used to seeing cosecant. So in order to graph cosecant, what we're going to be doing is basing it off the sine graph. So you're going to have to graph the sine graph first, and then every place that the sine graph touches the x-axis where there is an x-intercept, we're going to draw an asymptote. And then from the rest of the points, the maximum and the minimum points, we're going to be creating a parabola-shaped curve, or a U, or an upside-down U, which will bounce off each of these maximum and minimum points, and we're going to use the asymptotes as guides, like walls, that our graph will skim along. So in order to, I guess, help you understand this, if you think about the quadrant points again. So remember, we have 0, which is 0 degrees as well, pi over 2, which is 90, pi, which is 180, 3 pi over 2, which is 270, and then we also have 2 pi, which is the 360. So if you think about back to the unit circle, remember how we use these ordered pairs for those quadrant angles, the 1, 0, the 0, 1, the -1, 0, and then here the 0, -1. So for example, if I wanted to do the sine of pi, remember in the unit circle, remember our R value was always 1. So we learned that sine, we could just get away with looking at the y. But remember at the beginning, we learned it was y over r. So my y value here at pi is 0. So 0 over 1. And again, we could have just looked at the y, and sine of pi is 0. But if you do the reciprocal, which is cosecant of pi, and we flip the r over y, we would now get 1 over 0, which is undefined. So at every place where our sine graph equals 0, meaning our x-intercepts, the cosecant graph will always be undefined. And this is why we will draw an asymptote through those x-intercepts, because for the cosecant graph, there aren't any points on that graph. It's like a wall, a boundary. So let's go ahead and review how to graph the basic sine graph. If you recall from yesterday, remember the sine graph always starts at 0, 0. And then from there, if it's doesn't have an amplitude, or if it's not a negative sine graph, it's always going to go up to 1 at pi over 2. Then it goes back down to the axis at pi. Then at 3 pi over 2, it goes down to -1, and then back up to the axis at 2 pi. We complete the same cycle or the same pattern going over here towards the negative side. At negative pi over 2, it's -1. Negative pi, it's back to 0. At -3 pi over 2, at 1 again. And then at -2 pi, back to the x-axis at 0. So now that you get your sine graph on here, now every place that the red graph, the sine graph, touches the x-axis, I'm going to draw a vertical asymptote. I'm going to draw my vertical asymptotes in green. So I have one going down here, here, here. Every place that my red graph touches the x-axis, the x-intercepts. Now all the other points that I did not draw an asymptote through, this maximum point here, I would draw a parabola shape or a U, using the asymptotes as the guide to see how wide to make that U. Then at this minimum point, make your U shape. Over here as well, at this maximum. So at every point that does not have an asymptote through it, you're going to create the cosecant graph. Now, when you go to do this on the test, I only want to see 2 cycles here. So I have a cycle which goes from 0 to 2 pi on the right, and then from negative 2 pi to 0 on the left. So if it helps you to box it in or make a rectangle around it, you can draw a rectangle around your farthest point to the left and your farthest point to the right. And I only want to see the graph within this box. Once you're done, I don't need to see the sine graph anymore. So if you want to erase the red line, you can. I know sometimes once you graph it, it's hard to erase, and sometimes you start erasing your points. So if you just want to take your pencil and then sort of like shade over it, just to tell me that, pretend like this isn't here anymore. Because the only thing I need to see as your answer are the yellow and the green. I don't need to see the red. So if you want to erase it, you can. I do have a box of colored pencils that I could pull out, and you could color code it. You could say the cosecant graph is yellow, the asymptotes are green, and the sine graph is red. Either way. For those of you at home, you could color code it if you wish, but you don't have to. So this is how we would graph the cosecant graph. It's always based off of the sine graph. Let's go ahead and take a look at the secant graph. So my secant graph is going to be based off of the cosine graph. So again, we're used to seeing the abbreviation, which is SEC, and for cosine, COS. Here again, every place that there's an x-intercept, after we graph our cosine graph, we're going to draw an asymptotes. And then again, same thing like with the cosecant graph, we're going to have parabola-shaped curves that are going to bounce off those maximum and minimum points. So let's review how we would graph the cosine graph. Remember, the cosine graph starts at 1. Unless there's an amplitude, then it would start at that amplitude. So I'm starting here on the y-axis at 1, and then from there, from that amplitude, you always go back to the axis. So at pi over 2, I've got a point on the axis. Then at pi, it goes below. 3 pi over 2, it goes back. And then at 2 pi, up to 1. Then over here, from the y-axis, it goes down, then down a little bit more, back up, and back up. Now again, I highly recommend that you box it in. So I'm going to draw a rectangle. So you're going to draw a rectangle, and that's so lopsided. Okay, so you're going to draw a rectangle around the lowest point and the highest point. Now, once we've got our graph on here, now we have to draw our asymptotes in. So every place that my red graph touches the x-axis, I'm going to draw an asymptote. I have one here. I have one at negative 3 pi over 2, one at negative pi over 2, one at pi over 2, and one at 3 pi over 2. Now, at the maximum and the minimum points, I'm going to draw the parabola shapes. Now you're going to see on this one why I need to box it in. Because over here, when I go to draw the U, I don't want to see this left side of the U. But if it helps you to see how it curves in, you could draw it there, but then erase it. And then over at this minimum point, make your other parabola facing down or your upside down U. At this maximum, draw one here. The minimum, draw one here. And then over here as well. And again, if you're not sure which way to make it curve in, draw the U shape, but then erase the one that's outside of your box. Because I only want to see 2 complete cycles. I don't want to see any more than that. All right, so now let's try to do one where a period change has happened or an amplitude as well. So this one, we're going to go ahead and graph the secant graph. But before we can do that, we need to graph its reciprocal. So we have to graph the cosine graph first. So let's go ahead and identify the amplitude first, which is going to be positive 2. The 1/2 I'm going to use to calculate my period. So I'm taking 2 pi and I'm dividing it by 1/2. So I do a keep flip change and I get 4 pi. So my period length is 4 pi. Remember, when there's not a horizontal shift, I take that period length and I break it into quarters. Multiply it by 1/4, 1/2, 3/4. And again, I can show the 4 over 4. So this simplifies, becomes pi. This also simplifies, becomes 2 pi. This one simplifies, becomes 3 pi. And 4 over 4 is 1, so 4 pi. These are going to be the points that I label on my x-axis. Remember, when there's not a horizontal shift, it's like a mirrored image. So I could just put negative signs in front of all these and put them on the left side of the y-axis. So let's go ahead and set up our x and y-axis. This time I don't have little boxes to count. I'm just going to space all these evenly apart. So let's go ahead and graph. So I'm going to put pi right here, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Remember, it has an amplitude, so I'm going to put a 2 here and a negative 2 here. Remember, the first graph I'm creating is the the cosine graph. So I'm graphing this first in blue, and then I'll go ahead and graph the secant graph in red. So remember, the cosine graph always starts at the amplitude. So I'm going to start it up here on the 2. From the amplitude, it always goes down to the x-axis, or goes to the x-axis. Then from there, it'll go down again, then back up to the axis, and then now back up at 4 pi. Complete the cycle to the left, down, down again, back up, and then back up again. Let's box it in. So when we go to add in our secant graph, we don't put in more than what we need. So again, over here at the negative 4 pi and the 4 pi, this is where I'm going to make my rectangle go around it. Now I'm going to draw in my asymptotes. Every place that my blue cosine graph touches the x-axis, that's where an asymptote is located. So I have one here at negative 3 pi. I've got another one at negative pi, another one at pi, as well as 3 pi. Now I'm going to go ahead and make my parabola curves here. And again, if it helps you to see the full U shape when it's a part of a U, you can always draw the full U, but then go back and erase it. So up here at this maximum, I'm going to draw a U. But again, remember, I don't need that left side of the U that's out of the box. So you could put it there so you know which way to curve that side, and now erase it. Then down here at the minimum, make your parabola. Up here at the max, and again another minimum, and again only half of the U here. And this is your secant graph with an amplitude and a slower speed. Next, we'll do an example of a cosecant graph. So we'll graph the sine graph first. Next, we're going to graph a cosecant graph. Remember, it's based off of the sine graph. So what we have to graph first is y equals negative sine x minus pi. Now this one is a phase shift. It's shifting it horizontally. I am going to be shifting this graph to the right pi radians, or 180 degrees. So for the phase shift, or the horizontal shift, we don't use the 1/4, 1/2, 3/4. We're going to add 90 degrees, or pi over 2 each time. So I'm going to go ahead, and my starting point is pi. I'm going to add and subtract 90 degrees. So when I add 90 degrees, which is pi over 2, I need to find a common denominator. My common denominator is 2. This becomes 2 pi over 2. I'm going to add them, and I get 3 pi over 2. My next point, take that 3 pi over 2, add pi over 2 again. I need 4 points that are going to be to the right of pi and 4 points to the left of pi. So once I add this, I get 4 pi over 2, which reduces to 2 pi. Now remember, I could use 2 pi and add pi over 2, but then I got to go back and find a common denominator. So remember, I'm going to take the unsimplified fraction to add the pi over 2. So I don't have to find a common denominator. And now I have 5 pi over 2. So far I found 1, 2, 3. I need to get one more point that's to the right of my starting point. So 5 pi over 2 plus pi over 2 gives me 6 pi over 2, which reduces to 3 pi. Let's do the calculations for the 4 points to the left of pi. So I'm going to take pi, and now I'm going to subtract pi over 2. Again, common denominator. Pi becomes 2 pi over 2. And when I subtract pi over 2, I get pi over 2. Because think about it. You're doing 180 minus 90, which gives you 90. So my first point to the left of my starting point is still to the right of the y-axis. Let me do it again. My next point, so this is the first point to the left. The next one to the left of the second one to the left of the starting point. I take pi over 2. I minus pi over 2. And now I get 0. So my y-axis is actually a stopping point this time. Usually it's not. When your shift is 180 or if your shift is 90, you will have a stopping point on the y-axis. Let's do it again. So this is the second point. I need to get a third one. So subtract 0 minus pi over 2. This is the third point. And now I need one more. Negative pi over 2 minus pi over 2. Negative 2 pi over 2, which is negative pi. Now at first glance you're going to think, oh, this looks lopsided. You only have 2 negative numbers. However, there's still 4 points that are to the left of the starting point. So let's graph them. So here is my axis. That's kind of wavy. Let's straighten it up a little better. Okay, so now I'm going to evenly space them. So I have pi over 2, which is 90. I have pi, which is 180. 3 pi over 2, which is 270. 2 pi, which is 360. And then I just keep going. This is 5 pi over 2. And then lastly, 3 pi. Because remember, this is where we're starting, but there's 4 over here. And that's your goal. Now I'm going to put markings for 4 to the left. So again, remember, this is the first one to the left. The second one to the left is on the axis, it's 0. And then the third one is the negative pi over 2. And then finally the fourth one is negative pi. So I actually have in this picture, even though it doesn't look like it, there are 4 points here that are to the left of pi. Because I have the pi over 2, the y-axis, this is the third one, and this is the fourth one. So now we can graph the sine graph. Let's graph it. Remember, the sine graph usually starts at 0, 0. But remember, we have a shift. So now instead of starting at 0, 0, I'm going to start at pi, or at pi comma 0, because I'm not rising up. Let me add in my amplitude as well. Again, you could have thought of this as a -1, but I'm going to put a +1 here and a -1 here. So from 0, 0, the sine graph usually moves to 1, but it's going to move to the amplitude. So it's going to go to -1 after the pi. So here, I'm doing this in blue. And then back up again, and then back down. Let's go the other way. We could connect these. Now let's go in the other direction. So it's going to go up, down. We do have a stopping point there because it is 90 degrees apart. And then we end up here. Let's go ahead and draw our rectangle around our lowest point and our highest point. So the lowest is the negative pi, and our highest is the 3 pi. Let's draw in the asymptotes now. I have one over here at negative pi. I've got one that's the y-axis. Got another one at pi, and then another one at 2 pi, and then another one at 3 pi. Now I can go ahead and draw in the actual cosecant graph. Again, all of the points that are the maximum and the minimums are going to get the parabola shape connected to them. So I have a U that's located here, and here, and here, and lastly above the 5 pi over 2. And there is your cosecant graph with a horizontal shift to the right, pi radians, or 180 degrees. So be able to graph the sine, the cosine, the cosecant, and the secant graphs with shifts horizontally, vertically, and a period change, where we're either going to speed it up or slow it down. So again, you have a WebAssign assignment. Start getting yourself organized for Wednesday's test. And I'll probably be posting a review that you can start on over the weekend if you wish, but we will spend Tuesday reviewing. And then after the test, we'll continue on and cover the tangent graph.